Hello and welcome. My name is Chad Teets, Wireless Field Application Engineering Manager. I would like to introduce you to Patrick Chiang, Anritsu's Wireless Field Application Engineer. In this video, Patrick will be demonstrating the MX8010A 5G RF measurement software. This demonstration provides a high-level look into the various windows and parameter settings you will most commonly use in the RF measurement software. Thank you again for choosing Anritsu Test Solutions. Enjoy the demonstration.
I launched the GUI of the demo. So this is the setup of the demonstration. So you can see because the device is a commercial device which only support NSA. So I need to have a 4G anchor. So on my left-hand side, on the left-hand side box, it's our MT8021C. It's acting as a LTE anchor. And on the right-hand side, you can see that's MT8000A. So the output of the two boxes are combined using a combiner and then feed it to a shell box in the middle. And then on top of the MT8000A is a Windows laptop. And then showing you the RF measurement GUI that I'm gonna showing you right now. So also, other than RF cables, there are two cables connected on the MT8000A. You can see that in the middle top, there's a white Ethernet cable. So this cable runs to the control PC. And then there's also a BNC cable, the synchronization output. This will be fed to the MT8021C. So that LTE base station can be synchronized with the 5G base station. Okay, then let me switch to the GUI. So now you are seeing the window of the laptop of the control PC, the controlling the MT8000. So in the GUI, we have two windows. This is the NR window, and then we also have LTE windows here. So, and then assuming you only interested in NSA, so you probably don't care about the LTE window. You just need to focus on these NR windows. I'm gonna go over the GUI step by step, and then on the right-hand side is the I'm using the visor to control a commercial device here. So later on, I can turn it on. Okay, so in this GUI, it's named as MX8010A. So it says TDD measurement software, but in fact, it also because when it was launched, only TDD was supported. So we still have the name say TDD, but in reality, it can support FDD as well, like what we are testing today. So and then we can test PCC and SCC1. So right now, the support 2 CAs, but the device does not. So we just do PCC. And then let's see, okay, on the top, let's see on the top. So on the top, it will show you what's the current connections, right? So this is the bottom two RF modules. And then right now we are using only the first RF modules. And then there are 6 commonly used parameters that we put on top, so you can easily change, like channel bandwidth. You can easily switch between the channel bandwidth. Power control pattern, you can do auto, that means it will follow the input level, or you can do all up or all down, or stay put. And then this for you to set the uplink and downlink channels. and then this say you set the output levels. And then in the middle, these are measurement display screen, and then here the signaling tab. So once the UE register, we will show you the UE capability information, and then the supported band. So we can actually turn it on now. So you can see the UE now is now connected on LTE, and then we already got its UE capability information, right? So it says I'm release 15 device. Doesn't support 60 kHz SCS, and then these are the MRDC, which is ENDC band I supported. So this is a very handy feature because when you got a device from supplier, you don't know exactly what. They will say, or you got a device from somewhere, and then you don't know what other band it supports. So you just need to register on LTE, and then we will tell you what other band it supports. Of course, this is based on the. So how do we know that? Because when the UE register, the network will query its capability, and the UE will identify its capability, and then we decode that message for you. Yeah. So we have seen some prototype device. Their reported band does not match what they actually can do, but still, this is a good. But for commercial device, this should be true. Yeah.
So did you have to put a Enritsu SIM card inside the phone to have this registered?
Okay, good question. So yes, the quick answer is yes. So because we are simulating a network, right? So the UE actually, when it registers with our simulated network, it believes I am on a real network. So how does we do that? So we need to put a test SIM card. If we put a live SIM card, then if UE can still register with our call box, that means that the live network security is breached, right? So nobody should be able to simulate a live network with that makes sense, right?
Yeah, just making sure.
Yeah. So Enritsu have a couple test SIM cards we will offer, and then we define here in we let you choose SIM card models. So once you select the SIM card model, the authentication key and the algorithm will change accordingly. So this happens in all the cellular test systems. Yeah, you need to have a test SIM card. So I don't know if you need to test a device with eSIM, which doesn't need a physical SIM card. So in that case, you will need to work with the eSIM vendor to load any test SIM profiles. So, and then they need to tell you what is the key, authentication keys. So then you can enter here. And what's the algorithm, right? So in the live network, people, it always use mini-notch, but 3GPP use XOR. Okay. So I just went over the UE capability information. And then also, the base station can also ask the UE to report what other power is received, right? So same as the base station emulator here. So let me enable it, and then let's try to. So once LTE is registered, we can start a call to bring up the 5G. So now it's connected. So you can see the UE now report 73 for ISRP, which is corresponding to negative 84 dBm per 15 kHz. So I can show you quickly here. Let's say if I change my output level, right? So here, let's say I reduce, I increase by 10 dB. So you should see this RSRP increase, right? So this does work. It is not fake, right? Okay. Go back 10 dB and then go back down. Okay. So then we also have other feature called show trace. So later on when you debug your NSA signaling, so you will need to know, okay, why my UE doesn't register because something wrong. So this will give you the real-time trace, which is nice, right? You can see the protocol log. Even though this is an RF test solution, but we still offer you the protocol trace log tool when you need it. Oh, and then in the tool, you can select the capture filter. That means you can capture each channel and primitive and each layers. So this is a very powerful tool that we offer. And then we just add the 5G carrier. So although this is NSA, all the signaling coming from LTE, but when we add the 5G, you can still capture the PREG here, message of PREG. Right, you can see all the details, right? When receiving system frame number and timing errors, power values. Okay. So next, let's show you the measurements. So once you connect it, right, you have an NR connected here, showing here. Then we can do the single measurement, just like a spectrum analyzer. You press single, that's a single sweep. So you do single measurements for every item you enabled. So this is the default screen, but we can change the layout. So on the top left, it gives you a basic summary in numerical form, and then the others just in graphical. So you can see occupied bandwidth, you can see spectrum emission mask, adjacent channel power, in-band emission, spectrum fatness, EVM, phase error, magnitude error, and constellations, right? So if you want, you can go into each one in detail. Like, for example, I want to see, click on it, and then I can expand each column, each field to see details, right? In numerical. Okay. And I can shrink it, and or I can go into occupied bandwidth. I can move my cursor. Move my cursor markers, and to show you the detailed numericals here. And one thing is we can either change the RBs, right? So right now it's full, this is a 15 megahertz bandwidth, so it can accommodate 69 RBs. But in some of the test cases, you might want to change the number of RBs. For example, I can change to like 1 RB, which only, and then starting position 0, and then do a measurement. So this gives you a measurement that, okay, I now have UE, tell the UE, transmit only 1 RB, and the starting position is 0, which is on the leftmost side, right? And then you can measure how it's mirror, right, is and the carrier leakage in the center. And you can see the call is still on. The call is always on. The call doesn't drop. So we can change the number of RV on the fly, right? So now I can change on the right-hand side. Oh, sorry. I want to still do 1, but I want to starting at 78. Let's do a measurement.
Does the current setup that you have allow you to run any RF test cases, or only measure RF parametrics, or look at RF parametrics at this point?
Yeah, we only look at RF parametrics. So you're talking about RRM?
RF test case.
Basically, it covers the 3GPP Chapter 6 and Chapter 7. It doesn't cover Chapter A and above.
What I'm saying, with this configuration you have right now that you're demoing, can you set up an RF test case, or not at this point?
So this is the in the GUI, it doesn't specify a specific RF test case, but you can see the test case actually are covered, right? So here, occupied bandwidth, right? Spectral emission mask. This each corresponding to a 3GPP test case at adjacent channel. Yeah.
I understand, but can you set up a test case to run and so I can see a pass-fail criteria in the demo, or not?
No, we haven't. We in our automation tool called ATS, we have that feature, so it can be automated. But in this GUI, it just provide you a general R&D purpose test.
Yeah. So, are you going to show the ATS automation tool?
I can show you a video later. Yeah, we have a demonstration video I can show you, but I don't have that software here.
All right.
So the ATS basically is send GPIB command to this GUI to automate the test. Yeah, and then they have a 3GPP quite a judgment criteria built in, so they can tell you pass or fail.
Got it.
But in our LTE solution, actually we have that, but we in NR, I think we will add it later, in the GUI. Yeah. But right now, the automation software will do the job. Yeah. Okay. So if you like, you can also run a continuous test. So the test will run over and over. Right. So let's look at the constellation. So right now we are doing QPSK, right? So we can easily switch to 16 QAM. I think we need to move the cursor to better position. So. Oh, because we are only doing the 1 RB. Okay, so that's 79. Okay. Yeah, so you see 16 QAM. Okay. And then you can switch to 64 QAM. So very easy to use, right? So
can you go to the emissions plot?
Okay, sure.
Yeah, SEM. All right. So you already have predefined limits?
Yes. Yes.
Okay.
That's why it will tell you pass or fail.
Okay. And those limits are from 3GPP?
Yes.
Okay.
Yeah, so it'll give you a pass here.
All right.
Okay, so there are other measurement items. So this is called fundamental. So measurement item is fundamental, which is you can turn it each one on or off. Power temp, occupied bandwidth, spectral emission, this and modulations. So I'm gonna show you like power control tolerance. This is very cool. I like it. So in this, you will see power control template, TX measurement. So there are different test type, right? Absolute power. So this just tell UE to go to a specific power, and then we do the measurement. So basically what it does is it transmits at the low power for the subframe 0. Yeah, this is 0. I think the 0. Yeah, and the negative 1, 2, 3, 4, and then suddenly jump in one subframe, and then capture the power. So you can see this power. Yeah. So these are defined by 3GPP, right? So this is okay. So next thing we can do a ramp up.
Is this under a closed loop condition?
Yes.
Okay.
Otherwise, yeah, because a device, mobile device, how much power can the mobile device transmit is not up to the device. It's up to the network.
Mm-hmm.
So one of the RF performance that we need to make sure UE can do is that how accurate it can control its power. Right. So this has let UE increase 1 dB by 1 dB, right, per slot, I think, and then it will measure the difference, power difference here. So we will tell you what's the worst case here. Yeah, and then you can see the detail list. Yeah, here. So this is based on the 3GPP's definition, right? And then this is ramping down. Yeah.
Can you show the max power this device can output?
Okay, sure. So very easy. So we just go back to normal and then to fundamental. So in order for UE to transmit maximum power, right? Right now we have usually people would do is we just change the TPC pattern to all up, right? But before we do that, we want to make sure our equipment receiver is ready for that high power, right?
Mm-hmm.
So we want to change the input level to higher, like 25.
Mm-hmm.
And then before I do that, you can see the TPC pattern actually tell the UE to follow, right? So the UE actually already increased the power. So let's do this. It's already raised up the power from 0 to 17. But so right now we can almost make sure the UE can only transmit 17. But if you want to double confirm, you can change this TPC pattern to all up to see if UE actually it increased. Yeah, it doesn't increase very much, right? So the easy way to see the a device how much power can transmit, just simply change the input level. So this input level has two meanings, two purposes. So first, it set up our receiver of the equipment. Hey, be ready for this high power, right? And then second is, if the TPC pattern is auto, it will automatically tell the UE, hey, try to catch up, try to adjust your power so I can receive at this level, right?
Do you know why the UE is not going up to 23 dBm?
Okay, maybe because my pass loss is only set up for downlink, right? This is FDD channel. So currently my pass loss, I set up for the same for 36 downlink and uplink. So I have remember I turned on the measurement, right, report here. So that's how I estimate how do I know my pass loss? I don't know, right? Because this is just OTA, right? I don't have so how do I know the pass loss? Because I estimated by seeing how much power UE say it received. So I know how much I transmit, right? I know I transmit negative 85.8 per 15 kHz. And then UE says, okay, I'm receiving negative 87. Okay, so I actually need to add 2 more dBs, right, on my pass loss. So let me add 2 more dB on my pass loss. So let's check again. So now I'm still transmitting negative 85, and the UE says, okay, 85, right? So now I know my downlink pass loss is is estimated correctly, right? Given that UE is calibrated for downlink. However, I still have no idea about uplink pass loss, right? So you can see I just set it the same. Right? 38. Which may not be the case because it's a FDD channel, not TDD channel. If it's a TDD channel, yeah, I can assume the downlink and uplink are the same, has same pass loss. So now the UE, okay, you see the power result going higher a little bit. So this means the requirement. The requirement, I think, is 19 dB, the lowest limit. So the pass loss does matter on the power value you measure, right? So in the beginning, but if you do conducted, then you need to compensate the cable loss as well, right?
Yeah.
And then this number need to be from your vendor or OEMs. Yeah.
Can you demo a sensitivity measurement with throughput and blur?
Okay. Yeah, I can show you the basic idea, but right now I don't have. I need to work on there's some parameter setting that make the throughput not 100%. But I can show you the idea, how it works. So in order to do a receiver test, you need to turn on throughput, right? And then we can turn all other off because we don't care. Okay, so you can see the downlink throughput is 100 right now. So in order to do the sensitivity test, all you need to do manually is just lower down the power of downlink. Okay, still 100. So let's going down further. 10 dB. Going down further. Oh, okay, you can see the throughput drop, right, by like 1%. So now you can fine-tune by 1 dB, going down. Okay, so now you can see the throughput is about 95, which is about the right here. And then if you want, you can do some average. You can increase the number of frames to 1. So that means you can increase the average. Yeah, so if you know that if you keep dropping the power, then the throughput will be less than 95, right?
Mm-hmm.
And then here you can also see the error counts for NAC and the DTX.
How many total transmitted blocks do you usually monitor?
So this gives you the number of frames here. So you can use a transport block or frame. So right now we are using the number. It means how many frames. You can also use transfer block if you want. That means it's 10,000 block.
How many transmitted blocks do you transmit in order to get an adequate throughput or reference or sensitivity number that you can rely on?
I remember we usually put 10,000.
Okay.
Yeah. But we need to check with 3GPP spec if you want to follow them. Yeah.
Mm-hmm.
I usually just put 10,000 here.
Yeah.
I know 2,000 is just, the 2,000 is our default, but it's not that stable. Yeah, it varies a lot, right? So I usually put 10,000. Okay, so let me show you a couple nice features in the GUI. So in the middle, right, right now we only focus on middle screen, which show you measurement result and the signaling informations. And then actually the parameter settings on the left-hand side. So on the left-hand side, let's look at the bottom first, system config. So this give you the overall system information, serial number, time, and the slot configurations. So in the future, if you get a box, you will know, okay, how your box is configured, and then what are the software options you have. And then this also show you the RF routings. You can routing through main port or aux port. In case you want to do like OTA test, you may want to separate the downlink and uplink RF ports. So right now they are all combined in the main port. Okay, and then external loss. This is a huge task. So remember I mentioned that it's very important to set up the correct path loss before you do power measurement. So, and then this usually the path loss varies on frequency, right? Even you have a cable connected. The cable is a frequency dependent, right? If you can use a VNA to do a sweep, then you know the path loss for each different frequencies. So our GUI allow you to enter different path loss for different frequencies, right? Like here. So you can make it a table, and then you can save it, or you can load it later. And then once you enter it, you can make it a graph. So this is a graph we made for this cable. So you can load up to 6 tables, which is very handy. Yeah. So it means maybe 6 different devices or 6 different cables. Yeah. But if you say, "Hey, I just want a quick measurement. I don't have the measurement of cable loss handy. Can I just do a quick measurement with one single loss value?" Yes, we support that. So here, when we set the loss value, you can decide, okay, do you want to turn off or turn on or use common? Common means a table, yeah. The reason why we say common is because in the 2G, 3G, 4G era, we can set when the table usually apply to all reds, right? So it's common to all the reds. But so we just follow this GUI is the same as our 4G GUI, so we just follow the same terminology, say common. But in reality, it just means the loss table. And then if you switch to on, it's just single value apply to all frequencies. It's kind of quick and dirty measurement.
What if I want to add, like, let's say a 10 dB attenuator along with my cable loss? How do I set that up?
How do you add it up? Okay. So
add a 10 dB attenuator between the UE and the box.
Do you already have a cable loss table here, or you don't?
Add the attenuator with the cable loss.
Okay, assuming you already have this loss, so
yes.
You can actually make a copy of this, save, and then add 10 dB on each.
Oh, okay.
Yeah, because these settings are exclusive, so you cannot have both active. So either you select external loss with this single value, or you select the common to apply the load table.
Okay.
Okay. So this is external loss test parameter. So this is how later we're gonna implement the 3GPP test parameters. So you can easily switch to test cases like maximum power or spectral emission mask with a partial RB or something like that. So we have, in this version of GUI has an implement. I will check if later version has it. If you are interested in see another demo. Then fundamental measurement, as I showed earlier, this let you turn on and off on each single measurement items, right? And then for most of the transmitter measurement, we capture the waveform and then do the post-processing. So it happened in only one time. So if you turn on more, it doesn't mean it will take longer or much longer. It may just adds a little bit post-processing time, but the waveform capture time is the same if you turn on all these transmitter measurements. But throughput measurement usually take longer because you need to generate more blocks and then let the UE report how good it is.
Can you demo some fading conditions?
I don't have that feature right now.
Oh.
So, but I can show you some of the settings. Oh, it's not in this version. Okay. Yeah, sorry, it's not in this version. And then this gives you all the detail of each channel parameter settings, SS block, PDCCH settings, PDSCH settings. So as I mentioned, this is callback solution, right? So it tries to offer you as much flexibility as we can for the UE bring up and then the debugging, OCNGs and the dynamic spectrum sharing. So we already support that. You don't care about that because it's an NSA feature. CSIRS, you can turn it on. PUCCH. Yeah, so a lot of settings you can play with. So this is very different than the conformance system. In the conformance system, you probably cannot access those detailed parameters. Usually you just can check which one to run, and then that's it. Pass or fail. Okay, so then for so there are so many parameters you might want to change, right? So let's say, oh, how do I find my parameters? So, okay, we have a find here. So let's say I want to change MCS or modulations, MCS. So this gives you all the MCS settings. And if you click on it, it will point out to there. So remember, we just changed the modulation to 64 QAM, right? So let's say if you don't even remember MCS, you only remember modulation, okay? Happy modulation. So here it gives you all the modulation parameters. And then you can point out here, you can bring up to the actual GUI. So it's very handy. And then now you can switch back to QPSK. And then do a oh, the call is dropped. So we need to make another call. Because we reduced the power. Remember, when we were doing sensitivity, the power was too low. Okay, so let's increase. Then let's put the power level. Yeah, then we need to restart. Yeah, that's really low. So there are parameters we can just recall. So you can, let's say you change the parameter just like I did, and then everything doesn't work. You can recall a predefined parameter set. And it will take a few seconds, and then once done, you'll say, okay, recall complete. So let's do this. Something wrong. Yeah, let me focus on the demo here. So, and then the other feature is a favorite. So let's say you often change some parameters, so you can add something to favorite, right? So for example, if you often change modulation, you can right click the mouse, and then there's a add to favorite. You can add to favorite. So now if you press the favorite button, there's a default bookmark. There's a user. So here we just added modulation, right? So now you can easily change from here. And then on the favorite, there is also a bookmark default. This right now is empty. Or you can see what's the history parameter we have changed. So this is also useful because sometimes you change so many parameters and then you forgot, oh, what have I changed? So this gives you an idea what you have changed. Okay. And then this just goes to expand. When you are not doing measurement, you are just focus on changing parameters. You can see more parameters in one single screen. And you can expand each column to see the detailed parameters. Expand all. Okay. Yeah. And then on the tool side, we can save all the measurements. You can save all screens or copy the current screens. Save all screen will generate a HTML file that you can share with colleagues. It's generate a really nice HTML test report. And then you can also save logs if you want to report any issues to Enritsu. You can save all internal logs, including everything, or you just want to save a remote trace log or a specific trace log. And then you can share with Enritsu. And then also calibration. So if you have time, you have to calibrate full calibration among all frequencies. And then, or you can do a frequency calibrations on that specific frequency range. Okay.
If you save a file that's really big, and then you try to submit it through the support portal, and if there's a limit in the support portal, do you guys have a separate FTP site to download to upload a larger file?
When you are an Enritsu customer, you will be entitled to access to download a new firmware. But for support purpose, I don't think they currently have a website or FTP site. We just usually customer just use whatever share website they want, and then share the location they feel safe with us.
What I'm asking is there a limit to uploading a file size?
Usually, Enritsu does not run the file FTP server for customer to upload the file. As far as I know, I'm not sure about the system support, right? But for the callback support, I don't think there's a Enritsu maintained file server. But so we usually customers just put on whatever server like Dropbox or Google Drive they feel comfortable to use with. They can share with Enritsu.
But there's probably a limit to the file size you can upload to share to.
Like Google Drive, their limit is 15 gigabytes, so which is far more enough than usually the log here will not more than a couple hundred megabyte only. Yeah. And then if you zip it, it will even smaller. Yeah. I only see like a 10 megabyte or something. Yeah. You won't be that high. Yeah. As far as this GUI, yeah. Some other GUI like protocol test GUI, they may include more things. But for this RF measurement GUI, its log, I think it's usually a couple megabytes. So okay. General file sharing or service should be good enough. Okay, so this is all about the demo today.
I see an aggregation level. Mm-hmm. Can you demo any aggregation combos at this point or not?
Oh, you mean carrier aggregation, not aggregation level, right? So
yeah.
Okay, so carrier aggregation, right now there's no device that can do FR1 carrier aggregation. I can show you the LTE carrier aggregation.
Yeah, show me that instead.
Okay, so this is our LTE GUI. Let me bring it up. So it's connected. So there's a UE capability. So let's see what's the downlink carrier aggregation support. So you say I'm support band 66 and 2, right? Okay. So now I will turn the UE off and then I configure my base station. So from here, usually we have a bookmark, it doesn't work. So call signal. So channel coding is by default is 1 carrier. So now we want to, wait. Yeah, I don't think in this anchor GUI it supports the CA. Yeah, because typically when we do CA, it's here. It's called downlink CA RMC, not just RMC. Do you have a device that can support downlink CA on the NR?
I don't have a device at this point.
Yeah, so the GUI has it. So you can see it's showing, we can specify. So for PCC, now it's 66, and the SCC1, you can change to band 2, and then change to whatever bandwidth you want. And then you can decide, oh, do I have activation on when it's the UE registered, or activation off? So right now, I don't think this version of GUI it allow me to enable the downlink CA because it only has RMC option. It doesn't have a downlink CA RMC option here.
Okay, what's this IP data tab?
IP data. Okay, so on the 88, this is our 8821, our LTE box, right? On the left-hand side here, let me show you the picture. So right now I'm showing you the 8821 capabilities, which is our LTE box. So this 8821 can generate built-in, it can has a built-in iPerf server, can generate iPerf traffic. So that's why it has IP data tab here. So you can do ping test, you can do iPerf test. Yeah.
What protocol layer does it go up to?
So basically, if you call this a call box, it covers all the layers, right? So that's why, remember I showed you earlier, here, you can see all the trace logs, right?
Mm-hmm.
And then if you capture the filter, it can go all the layers. So if you call this a call box, it should cover all the layers.
Okay.
It's just what you do after you connect. So on the RF solution, when it connect, after the connection, what we do is do RF measurement. So the GUI is focused on RF measurement, right? But it should have all the protocol stack in order to make a call. If it miss any of the layer of the protocol stack, then the call cannot even be completed.
I also saw a mobility interrat function. Can you do anything with that right now?
No, because as you know, you can do maybe some reselection test. Mm-hmm. So like what we have in our LTE solution. Let's see if I can show you here. So in our LTE solution, you can do like cell selection, reselection informations. You can assign you a Q, RX, LAV, MINs. So you can let the UE decide, oh, should I select on this one? If the threshold, the power is over this level or lower this level, right? And then also you can do neighbor cell settings, how you want to tell the UE who are your neighbors. Right? And the UE should start to measure these neighbors if UE received a neighbor list. And then also there's a inter-red. So this is how we do the inter-red testing. So basically just allow you to do kind of a neighbor measurement. Yeah. So, and then this is the simplified GUI of the ATA21. So it doesn't show everything here. Remember, this GUI is now on the remote PC. Right, this GUI I'm showing the GUI running on the remote PC.
I see, okay.
Yeah, it's in a simplified mode of the actual ATA21 GUI. Yeah. So we cannot even do the CA now. So now I want to show you the video of that automation software. So up to now is what I just showed you earlier, right? You have a 4G window and 5G window and doing 5G measurement. So I'm going to play the video from here. So this shows you the GUI for the ATS software. So you launch the GUI, and then this is the GUI, and then for the ATS software. And then from here, you select the test plan editor. And then here you set up your test. This is a preset test that cover N78 test. And then initially you set up the equipment, okay. And then you have 8000 and the ATA21. In your case, SA, you don't need the ATA21, you just need the 8000, yeah. And then set the environment. And then you can record the file, that parameter file that was using for manual test. Okay, so here is the test case editor, right? So you can choose, you can pick any of the 3GPP defined test case, 6.2.1.3, okay, for example. You select your interband ENDC, which doesn't apply to you because you are only running the SA here tab. Yeah, SA only. But just showing for people doing NSA, this is what I do. And you can change the spec temporarily if you want to decide to make it pass or make it fail. Easier or difficult.
Does your automation allow over extreme measurements? Extreme temperature measurements?
If you want to add the temperature control, you can set up the external GPIB command. Usually the temperature chamber should accept GPIB command, right? And then this should be simple. You set to like 40 degrees Celsius, or you set to 0 degrees Celsius. And then by just one single IP command. Then in our ATS GUI, we allow you to send the command, to insert the GPIB command, so you can control your chamber. Yeah. And this is showing you, you can generate different format of the report. And this allows you to set a pass loss. So this pass loss is, you can set a pass loss here in this GUI and then later apply to the box. And just show you the version of the software. Okay, so now I think they're gonna run. So basically, just once you edit the plan, editor, test plan editor, and then go back to the main window and click run. So initially you will do equipment calibrations. If you see if the temperature has changed more than 2 degrees, and then the warning sign will be shown here. So it will do the calibration. So now the LTE connected and then did start the measurement. And the counter will running here. And you can see the 3GPP test case one by one has been executed.
What's the test time for a coexistence test case?
Coexistence for?
Yeah.
You mean existence with what?
I think there's a RF test case for coexistence for 3GPP. Or is that RRM?
Yeah, maybe RRM. Yeah, I don't remember in chapter 6 or chapter 7. There are other rates. Yeah, it's just single rate.
So what's the longest test case time for RF test case?
I would say the receiver test take longer than transmitter. Transmitter test usually much faster than the receiver. So, for example, sensitivity, especially you need to do a search, right? That take a long time.
So, what's the time frame that you can estimate?
I can't, because it depends on how much the step size of your search and how you could just see how long how many blocks you transmit to give you a result. So if you ask people who support the conformance system, they may give you an answer, because the conformance system it's easy. It's not much you can configure. You just click run and then they will give you a number. But I'm not actually supporting the conformance system. I'm supporting the R&D systems. So it all varies, right? So
okay, understood.
Yeah. So if you need to see the demo for conformance system, then Mike may help you arrange another demo.